Section 7.3, to be and not to be. Let's classify a statement as a tautology, a self-contradiction, or neither. A tautology is a compound statement that is always true. When every truth value in the answer column of the truth table is true, the statement is a tautology. So here's an example of a tautology that our answer column, everything we get when we put it all together, comes out as true. So if that all comes out as true, you say that's a tautology or logically true statement. So let's describe each statement as tautology, self-contradiction, or neither. Mornings are great and mornings are not great. That makes no sense. You can't say they're great and then they're not great. That is a self-contradiction. Alright, B. Mornings are great and pancakes are great. That's neither. That's very that's up to the person if that's true or false. That's not a tautology. That's not always true. Some people don't like pancakes. Some people don't like mornings. So that's neither. And then for C. Mornings are great or mornings are not great. That's a tautology. That is always true because there's no in between. It's either you think mornings are great or you think mornings are not great. There is no in between there. So no matter how you spin that, it's always going to be true because there's no way else to feel about it. Let's use a truth table to decide if the statement if I go to the concert and wear pink, then I go to the concert is a tautology, a self-contradiction, or neither. So the very first thing we need to do is go from words to symbols. So we have if I go to the concert and wear pink. So I already have two simple statements there. Our first simple statement is I go to the concert. That's P. We have a connector of and. And then we have wear pink. So that's another thing that we're talking about. So that's Q. And then we have this comma here. We have this comma. So looking at that comma, to the left of the comma, we have two ideas. To the right of the comma, we have one idea. So we're going to group here. All right, then we have the then, and I go to a concert. Going to a concert, we already said was P. All right, so we put it into symbols. Now let's put it in our truth table. So we have P and Q. Then we have if then. So remember, we always do parentheses first. So we're going to do inside the parentheses, opposite sides of the connector. So P is first, Q is second, and is third. When we're outside the parentheses, we're going to look for another letter. That's R. So we're going to do that fourth. And then our last connector is fifth. All right, looking at P, just literally that's just look at P. So we have T, T, F, F. And then for Q, it's just saying look at Q. So we have T, F, T, F. And remember for and, both need to be true because and is very strict. So true and true, that's true. True and false, that's false. False and true, that's false. And false is false. So now the parentheses are this column right here. Okay, now we're looking at R. R is just R, there's no negation. So we're looking at P again because it's no negation. So true, true, false, false. And then we're going to bring it together with if then. So if then, the only thing we care about is TF. Everything is true. So if we look, we have TT, that's true. FT, that's still true. FF, that's still true. FF, that's still true. So since our answer column is all true, this is a tautology. Let's identify statements that are logically equivalent. So notice that the truth values for both are identical, TF, TT. When this occurs, they are logically equivalent. So if you're working it out and you get the same answer column, that means they're the same statement. You're saying it just in a different way, but it's the same thing. Two compound statements are logically equivalent if and only if they have the same truth values for all possible combinations of truth values for the simple statement that compose them. The symbol for logically equivalent statements it's like a little 3 lines. We're used to seeing that for navigation bars. Also, you can use the like a double arrow, double line as well. It means the same thing. Alright, De Morgan's law. For any two statements P and Q, if you have negation P or Q, it's actually the same thing as negation P and negation Q. Vice versa, if you have negation P and Q, that's the same thing as negation P or negation Q. So because it negates it, it switches everything because the negation is the negative. Negative means opposite. That's why all the signs change to opposite. Negation. So if you switch it over, it becomes negation P. The opposite of or is and then we have regular Q, so the opposite of regular Q is negation Q. We're going to decide which two statements are logically equivalent. So we have negation P and negation Q, negation P and Q, and negation P or Q. So let's just see what we get. So for our first one, we have negation. Then we have parentheses. We have P and negation Q. So we always do parentheses first. We always do connectors last. And when there's a negation outside, that's our final step. So P, that just says write P, so T, T, F, F. Negation Q, that means look at Q and do the opposite, so F, T, F, T. And then we have and. So with and, both need to be true, so true, false, that is false. True, true, that's true. False, false, that's false. And false, true, that is false. Alright, now we need to negate. So if we negate, we have opposite of false is true. Opposite of true is false. Opposite of false is true. Opposite of false is true. And Q. So negation P says look at P and do the opposite. So F, F, T, T. For Q, that just says write Q. So T, F, T, F. And then we're going to bring it together with and. Remember, and both need to be true. So we have FT, that's false. FF, that's false. And then true, true, that's true. True, false, that's false. Alright, let's do the last one and then we'll compare our answers. So looking at our last one, we have negation P. And we have or. And Q. So negation P says look at P and do the opposite. So false, false, true, true. For Q, that's just regular Q. So TF, TF. And then for or, only one needs to be true. So FT, that's true. FF, that's false. TT, that's true. And TF, that's false. So if we compare our answers, we do have matching ones. I'll circle them in purple. That matches, and this matches. So A and C are equivalent. We're going to rewrite this statement using De Morgan's law. I will not study for this class, or I will not fail. So first we have to bring out the P's and Q's and stuff. So it says, I will not study for this class. So that's P, but since we see the word not, we know that's negation P. We have the connector of or. And then we have, I will not fail this class. So that's Q, but since we have the word not, that's squiggle Q. So we know that that is equivalent. If we go back to De Morgan's law, in De Morgan's law right now, what we're working with is this right here. Oh, I circled that in white. You can't see that. We're working with that right here. So we know we need to switch it to the opposite. which is negation, parentheses, P and Q. So now we're just going to rewrite this using negation P and Q. So because we have the negation, we say it is false. And then we have P. P represents I will study. Remember, we always take the positive. We have our connector of and. And then we have Q. We said Q is I will fail. So I will not study for this class or I will not fail is the same thing that saying is it is false, I will study, and I will fail. Let's write and recognize negations of compound statements. So if the video goes viral, it will be on TikTok. And we're given a logically equivalent statement, P if then Q is the same thing as negation P or Q. So let's first see what we have. We have if the video goes viral, so P. We have if it, that is the same thing as saying if then. It will be on TikTok, so Q. So right now we're working with this one right here. So we know that's going to be logically equivalent to negation P or Q. So let's rewrite it as negation P or Q. So negation P, that's saying, so P was the video goes viral, so the video does not go viral. We have a connector of or. And then we have Q, which it will be on TikTok. Let's write and recognize the converse, inverse, contrapositive of a statement. So a conditional statement we already know is P then Q. A converse is actually just flip it. That's Q then P. Inverse is literally the opposite, so negation P if then negation Q. And the contrapositive, it's like if you mix converse and inverse together, you flip the letters and you negate it. Alright, so we're going to write the converse, inverse, and contrapositive and conditional statement for if the painting is by Andy Warhol, then the painting is valuable. So our P is the painting is by Andy Warhol. Then our Q is the painting is valuable. So we have P if then Q. So if we want to write the converse, converse means you flip P and Q. So instead of saying Andy Warhol valuable, we're going to say valuable Andy Warhol. So if the painting is valuable, then the painting is by Andy Warhol. The inverse means you keep P and Q in the same position, but you inverse, mean you make opposite. So we're going to opposite P, opposite Q. If the painting is not by Andy Warhol, then the painting is not valuable. So for C, which is the contrapositive just means you flip everything. So we have negation Q, if then negation P. If the painting is not valuable, then the painting is not by Andy Warhol. Alright, example 7. Let P equal lobbyists play a key role in shaping public policy, and Q, campaign donations influence politicians' positions on issues. Let's translate the symbolic statement into words, then use the truth table to decide if it's a tautology, self-contradiction, or neither. Alright, I already actually did put it into words. So we have P and Q, and negation P or negation Q. Let's write it on our truth table. Alright, so we always do parentheses first. So 1, 2, connector last. We have another set of parentheses. So 4, 5, 6. And the last one is the connector between the parentheses. So to get the last one, we're going to be looking at 3 and 6 because 3 simplifies the left side, 6 simplifies the right side. So let's rewrite P. We have T, T, F, F. Q, we have T, F, T, F. Let's bring it together with and. So T, T, that's true. True, false, that's false. False, true, that's false. False, false, that's false. Let's move on to our other set of parentheses. We have negation P, so let's do the opposite. So false, false, true, true. We have negation Q, so we do the opposite. So F, T, F, T. And then we'll bring it together with or just one thing needs to be true. So false, false, that's false. False, true, that's true. True, false, that's true. True, true, that's true. Now we're going to be looking at this column and this column to give us our answer. So we have true and false, that's false. We have false and true, that's false. False and true, that's false. False and true, that's false. So since we have all false, that is the opposite of a tautology, it is a self-contradiction. When your answer column is all false, it is a self-contradiction. So we're actually going to take this and turn it into words. So we have P, which represents lobbyists play a key role in shaping public policy. We have a connector of and, campaign, and then we have Q, campaign donations influence politicians' positions on issues. We have another connector of and, and then we have negation P, so lobbyists do not play a key role in shaping public policy. We have a connector of or, and then we have negation Q, so campaign donations do not influence politician positions on issues. So you can actually read it that you're contradicting yourself.